Similarly, we are going to discuss the third property, that means memoryless of LTI system. Memoryless of LTI system. So as we already know the formula, the y of n equal to summation of k equal to minus infinity to infinity h of k into x of n minus k. The convolution sum formula we are using here. So now let us expand this one. So if I expand this one, I am getting y of n equal to, so on, it is coming from minus infinity plus, I can write here, say take k value as minus 2, then I am getting x of n plus 2 plus h of minus 1 x of n plus 1 plus h of 0 to x of n plus h of 1 x of n minus 1 plus h of 2 x of n minus 2 plus h of 3 x of n minus 3 plus so on up to infinity. So this is the expansion I have given. So already the general definition, if the system has to be memoryless, then it has to depend on only present value. Its output must be depend on present value of the input. So for this equation, the present value is only x of n here, this. That means this one, h of 0 into x of n. So this term is nothing but this will give the present value. What about remaining terms? So all x of n plus 2, x of n plus 1 are future, x of n minus 1, x of n minus 2, x of n minus 3 are the past values. Hence, so all these terms must be equal to 0 except this term. So the system is said to be memoryless. These all terms must be equal to 0 except this term. So that is the criteria for system to be memoryless. That means your h of n must be, which is equal to 0 for n not equal to 0. So mathematically we can write here h of n. So look at here, for n is not equal to 0, it should be 0. Look at here, n not equal to 0 means if you take n value equal to 5, h of 5 must be equal to 0. If you take h of n value as minus 2, h of minus 2 must be equal to 0. So only the term n equal to 0, your impulse response has to exist. So and this is only possible when your impulse response is a delta function, because you know already delta function only exists at n equal to 0. Hence, so the same condition, that is h of n equal to 0, that condition has been written in another form as c into delta of n. C is a amplitude scaling factor and it is an arbitrary constant. So if your impulse response is of this form, so then I can say that the given LTI system is a memoryless system. So and this is for what? Discrete time. Similarly for the continuous time, so I can write here for the continuous time, h of t equal to 0 for t not equal to 0, and the same it can be converted into other form, that is nothing but this is only possible for only unit impulse function c into delta of t. So and this is the required condition for an LTI system to be memoryless. So if it will not obey this one, then we can say that the system has memory. So similarly, so we'll discuss one more. So that is nothing but the last one, the invertibility of an LTI system. The fourth one, invertibility of LTI system, and I can call here one more term is introduced, deconvolution. So the general definition for an invertible systems is that, suppose if there is a system is there, so if you feed input signal, then we are getting a one output signal. From the output signal, so if it is possible to recover back the original signal, so then we can call it as a system is inversible, we are calling it as. So that is the general definition. So this definition so tells that there is a existence of inverse system. So look at here, so I am using one system, LTI system, whose impulse response is h of n. So I am feeding the input as x of n. Say I am getting output as a y1 of n. So I named as a y1 of n. So now this y1 of n I am going to feed to one system. So that system is nothing but my inverse system. I am writing it as a h inverse of n. That means impulse response of a inverse system, I am defining it as a h inverse of n. So I am feeding this y1 of n to this inverse system if it gives the original signal y of n. That means I have to get y of n equal to x of n I should get. So then I will tell that the system is invertible. So now here, look at here. So this invertibility of LTI system we are discussing, and y1 of n is nothing but the convolution operation between x of n star h of n. Similarly here y of n, I have to get x of n back here, which is equal to x of n only. So that means that is also a convolution between y1 of n star h inverse of n. So what is deconvolution here means? Okay, so obtaining x of n from x of n star h of n, that means convolution between these two means this y1 of n is nothing but deconvolution. So hope you understood. So now let us write here what is my y of n according to this, because these two systems are connected in cascade. So I can write here y of n equal to the convolution between y1 of n star h inverse of n. So now what is my y1 of n? So I am going to write y1 of n. y1 of n is nothing but the convolution between x of n star h of n. So now star h inverse of n. Now I am going to write by distributive property, because it obeys distributive property. So I can write here my y of n equal to x of n star h of n star h inverse of n. So I have to get x of n back. That means I should get y of n equal to x of n. So if x of n is convolved with this term, after that I should get x of n. So the only possible condition is that if it is a delta function. That means I can calling here x of n is convolved with the delta function, then only it is possible to obtain a y of n equal to x of n. So other than this delta function I am not going to get x of n. If it is if I use unit step signal or any ramp signal, I am not going to get, because x of n star u of n is not x of n. The only possible condition is if the convolution between, look at here, it is not a product, the convolution between x of n and delta of n is a x of n, as we have already seen. So that means the criteria, that means the condition for system to be invertible means the h of n, the convolution between impulse response, system impulse response and inverse system impulse response. The convolution between these two, if it yields a delta function, then I am calling it as the system is invertible, and this is for discrete time. Similarly, for the continuous time, the h of t star h inverse of t, if I get, which is equal to delta of t, so then the system is invertible. So this is the necessary condition for system to be invertible.